Great evening, everybody, and it's amazing to see you physically here after the corona, after the fifth wave. So thank you, everybody, for coming today. It's really pleasure to have Confluent first, right, Morad? First Confluent Weeks together, a meetup. We're hosting here Tim. Hi, Tim, how are you?
Doing well, how are you?
We are great, thank you. It's good to having you here, on the screen, but yeah, all come to see you here, but hopefully next time. I promise them there will be a compensation for that. Hopefully next time.
Yes.
Great, thank you, Tim. And also today, Natan we will hear him, and before we will start, I want to share with you something. I think this time of the year is really exciting time. We are just before the sailing season. Everybody in the world try to optimize to buy their merchandise in the Black Friday and the Christmas and everything. Of course, this is really happy time, except the sailing stuff. But one thing is, in Wix, this period is really, really interesting because, you know, we also manage shops, and this time of the year, we always want to be available and online. And I remember, even from Aviran, the VP Engineering, a war stories about, like, I think it was 2015, Wix, it's before the Black Friday, and everybody, like, a surprise, but a fear about what will happen. And we know that any spike in traffic, something that will happen, Wix is going to be down. And now, I think a couple years later, we took some actions. You will hear Natan and what action we took and what we did to help Wix grow exponentially and be a better place and much more resilient. And you will hear about that. So I hope you, by the way, how many people here use Wix or have a website on that? One? Okay. I hope in the online we'll get more. So yeah, Wix basically is a website building platform. Come to solve one thing, which is unsolving or creating simple flow to create your online presence. And basically, this is our mission. Any business or any people on earth to make their online dream come true. And it sounds like terrific and nice, but basically we are, I think we even more, 7% of the website in the world are hosted on top of Wix backend. I think last month I checked is 1.7 billion websites, and this is the number, and the number not growing linearly, just to understand the order of magnitude of the scale that we are facing. So nice to meet you all. I'm Avi. I'm part of Wix engineering group. You probably hear, or if not, I really recommend you to hear about how our organization is structured in the guild and startups. And what is good is help Wix go healthy and make the goals that we want to create. And in the recent years, we did a major transformation from website building platform to the cloud for businesses. And what does it mean? It means that we are not only creating a website, we're managing online shops. We have a functionality for advanced booking, scheduling, even payment clearing. I think we pass billion of a lot of the money in the merchandise go through our payment mechanism. And this raised the challenges, the engineering that we face. We grew dramatically in all scales, like teams, more traffic that we serving, and even our global presence to being totally fully distributed. And the picture that you see here is not the Starship Enterprise, it's the microservices clusters. Each rectangle is a microservice cluster getting traffic in production. This is a map that I took couple of months ago from New Relic, just for you to understand the order of magnitude of microservices and to get a better context about what Natan is going to explain. And on top of that, we also manage our Kafka clusters in a fully distributed environment. The scale of Kafka is not linearly with the potential traffic, is with the new flows that we're creating. It's even growing with the traffic, but new flows that the developers creating, business use case that we want to solve. And that creates quite a big challenge, and we always try to see how we can engineering fix it properly and gain the velocity for the entire backend engineer and even the entire engineer. So enough me. Natan, please.
So thank you very much, Avi, and welcome everyone. My name is Natan Silnitsky, and I'm a backend infrastructure team lead at Wix.com. And this talk is about Wix's Kafka-based global data architecture and platform. So how we made it relatively simple for Wix's 2,000 microservices to be able to produce and consume data no matter where these services are deployed around the world, and also no matter on which technological stack they are built on. And I will also talk about how we created tools and services that enabled us to have high resilience in our distributed system. We saw the huge scale and increase exponential traffic that Wix as built. So we also talk about how we manage that successfully. So this story is a story of growth. We managed to have, in a simple fashion, helping our Wix developers as an infrastructure team to easily handle the exponential growth in our scale. And a few years ago, we partially migrated, and it keeps increasing, to event-driven architecture based on Kafka for our microservices communication. And we did that, and we see how these, this change, this working in such an architecture, really is much more optimal for dealing with increasing scale, for dealing with failures in your distributed system with all these services, much better than the way traditional request-reply architectures work. And not only that, we also have other scaling criteria to handle. We are deployed globally, but also we have hundreds upon hundreds of developers working on these services, and they have all kinds of use cases that need to get support. And they also work on diverse technological stacks. So we will see how we tackle that with our own messaging platform we built on top of Kafka called Greyhound. So we have a quick introduction on Kafka, then a quick introduction of Greyhound, and then the main part is how we tackled two important blockers in our goal to have a single global data mesh, scalable data mesh at Wix. So the first one was our single cluster in each data center really got overloaded, not much with the amount of traffic that kept increasing, but more with the amount of topic partitions. So we had hundreds of thousands of topic partitions that every day were increasing, and that meant that the self-healing of the Kafka cluster, when you have some broker going down and then you want you fixing it and you bring it back online, we want that to be fast. But if you had, at least at the moment with Kafka, so many topic partitions in the same cluster, then that process of self-healing can take a long time. I know that with removal of Zookeeper, that will be better. But anyway, we decided to move to a multi-cluster environment, and we'll see how we made that really simple and easy in our platform. And finally, the whole topic of cross-DC communication between microservices. We know that it gives a lot of complexity for our services that need to be decided on which data center they are deployed, where are the services that produce the events, and where are the services deployed that consume them, how do they interact, all of that. We really wanted to reduce this complexity for our developers and keep things as simple as possible to really create our own global, scalable data mesh. So we'll start off with a very quick intro for Kafka. I assume most of you know how Kafka is run and built, and if by any chance you need a quick refresher, so we have a Kafka broker, and events, messages are produced to specific topics, and these topics are divided into partitions. And what's interesting here is that the Kafka producer just produces new events to the end of the partition. The partition is configured as a commit log and basically a file where you just keep adding stuff at the end. And that means much better performance than traditional message queues. And also, Kafka consumers then have a pointer to where they're currently processing events from the partition. And unlike traditional message queues, they actually don't need to remove physically messages from the queue. They just scan, and once they finish processing one message, then they can commit it. And if there's restart or something like that, then they will they will start off from the first non-committed message. And of course, with Kafka, we're talking about scale. Really easy to scale this operation. You just add more partitions and more pods in Kubernetes for your services, and that's it. And of course, we're talking also about how this infrastructure helps us to be more fault tolerant. Well, Kafka clusters, of course, have data replication, and these partitions are actually replicated across multiple brokers. So that's also something that we can work with. Okay, so that was the quick intro for Kafka. Now let's see what kind of messaging platforms we built on top of Kafka in order to help us with the growing amount of use cases, developer services, tech stacks, etc. So actually, we decided a long time ago already, when we first started using Kafka, I think it was 2015, that we won't use the Kafka SDK directly. We will have a wrapper layer on top, and we called it Greyhound. And a year or so, 2 years already ago, we actually decided to open source Greyhound. And we'll see what actually we provided for our developers on top of what Kafka has to offer. So almost all 2,200 microservices at Wix use Greyhound for their event-driven programming. And if they use Scala, then it's really simple for them to create a Greyhound consumer. They just specify the consumer group name, the message handler, which is basically the lambda that they have the processing code there, and a topic name. And of course, for producers, then they just produce to specific topic, and that's the way the setup is done. It's really simple. Now, in terms of what feature Greyhound offers Wix developers and global community that's using our open source version, so we have parallel consumption. So you have your pods in Kubernetes, your instances, and you can choose the amount of parallelism that you want to have in the specific pods. So it's maybe handling, 50 partitions, but you can play around with the amount of parallelism, the amount of fibers that are running your code. And batch consuming, very important in cases where you have bulk APIs. So it's really important that you actually handle these messages in batches, and then you can call other side effects with bulk API. Really improves performance. Then we talk about resiliency. Then we have consumer retry strategies, And here we can think about whether we allow for retries to be in order or out of order, but there are different flavors. But the most important thing here is that we have the distributed system with services running stuff all around the place, but we don't get immediate feedback like request reply. So it's really important that you get a successful completion of processing eventually, and that's what these strategies allow in services. Resilient producer, that's for cases where Kafka broker is currently unavailable to you, some networking issue maybe. So Greyhound just saves the events to disk, and then when network resumes, it can read the messages back, and that also works with Kubernetes, even for pods that are flushed out. We have a mechanism for that as well. Context propagation, so that's another very critical key feature for us at Wix, as we have the user context request incoming from the browser, and we want to know everything we can about this user, and then the flow goes around all our services, and we also have experiments like A/B testing set up there. For all this context travels fluently, automatically, and seamlessly around all our services, so they can always access this information, the request context. Very important for well-functioning microservices ecosystem. And also matrix reporting. So of course, Kafka provides matrix out of the box as well, but with Greyhound, what we do at Wix, we utilize it for higher level matrix, like for application level. So if you want to know on average or P99, how long does it take for your message handler, your actual processing code, how long does it take? Has it started to take longer and longer? And maybe you're starting to get lag alerts. So also with Greyhound, we have built-in lag alerts, consumer lag alerts, whenever there's a slow consumer. So all of this package really helps Wix with the event-driven infrastructure that we actually require in order to have a healthy, growing environment, production environment. Now, the original Greyhound library was built as a JVM library, so written in Scala. But we also wanted other growing parts of the services at Wix to also use it. So we created a Greyhound Sidecar. Originally, the Node.js services at Wix had their own like mini version of Greyhound. Not all features were implemented there, and it was also a less good experience for running in Node. So we decided to create Greyhound as a service. So this service is running alongside the main application in the pod in separate containers, and it just invokes the Greyhound library. And this container works with the gRPC API, protobuf API, and the Node application interacts with this gRPC inside the local host. So it's really good performance. It doesn't impact performance. And more importantly, with using the power of protobuf, it's really easy for everyone at Wix, no matter on which technological stack they're building their code, to actually interact with the sidecars. So we also have data organization services consuming events from the business microservices via Greyhound Sidecar, via the service. Also, our serverless functions utilize Greyhound service in a more complex setup, but everything is working with the same code base, the same engine of the Greyhound working in the JVM library. So we have freed everyone to work in their technological stack. And the fact that everyone is working with such a standard way of operating with event-driven design actually meant that all infrastructure had the power to do whatever they wanted on top of Greyhound. So other parts of Wix infrastructure created concepts of domain events. So whenever you update your database, you automatically send that your domain business object has changed, and the developer doesn't even need to set up Greyhound here. It just set up the domain event. Or extraction of business events to the data warehouse. That's all of the interactions of data developers is done without actually working in Greyhound, because that's done on a lower level. Task scheduling is also performed with Greyhound so that you can schedule stuff you need to do in the future in your services. And asynchronous queues. So a lot of stuff has been built on top of one on top of the other here to really get the best features that can utilize the power of event-driven programming. Cool, so that was a quick introduction to Greyhound. Now let's talk about our problem that we had, a Wix with cluster overload. So of course, each Kafka cluster is usually worked on inside the data center, because once you want to produce to a Kafka cluster in a remote data center, you're probably going to have higher latencies. So we used to have a single cluster in each of our data centers, and they became overloaded, like I mentioned at the beginning. Many topic partitions. The success of Greyhound and the event-driven programming style meant that the cluster just became too big for us at Wix. And what we decided to do is simply to create more Kafka clusters in each of the data centers. And so we partitioned it. We need to think about, wait, how will we decide which topics go into which cluster? So the decision was that we're going to do it by the service level agreements. So we have a cluster dedicated for Wix site owners that edit their site and configure everything. And that's a different SLA than site visitors visiting our sites that, of course, need to have the highest percentage of availability possible. So we wanted to reduce the blast radius and each cluster impacting its own segment. And that's how we decided to segment it according to which user is interacting with our microservices environment. Now, when a Wix developer wants to utilize this multi-cluster environment, then if they use the Greyhound API directly, all they need to do is, with the same Greyhound consumer and producer, just specify .cluster A, .cluster B. This is the cluster that I want to consume this topic from. And in case that they're interacting with higher level constructs at Wix, usually it will be done in protobuf. They just specify, I want to consume something, and it's found on this cluster. Now, this actual part is not found on the open source version of Greyhound. It's actually only on Wix private layer of Greyhound, but we are thinking about how to also introduce multi-cluster support for the open source version as well. And you may think to yourself, wait, but how do I actually know if I want to consume a topic, on which cluster is it found? So here we just have our back office. It's called Greyhound Admin, and it's a service that every Wix developer is familiar with. And they go to topic configuration view, and they type the topic that they want to consume, and they can easily see which cluster this topic is found on. Okay, so we solved the cluster overloaded issue. And now I want to talk about DC awareness. So we're talking about globally deployed services, and we have our services deployed all around the world in multiple data centers. So we have situations where we have different data centers serving different purposes. So we have the master active database currently found on our, let's say, main DC, and another data center will serve as master passive, right? In case we want to be able to handle failure and switch to the master passive. Now, other data centers may have the database in read-only mode, like it's replicated, the database is replicated from the main DC to the other DC, and it has the read-only database replication. Now, I want to process some event and save updates to the database. But where am I deployed currently? Am I in a DC that has a read-only replica? So what do I do here? So we wanted to reduce all this complexity from the developer. And now we'll see how we actually solved the cross-DC services issue in step-by-step fashion. So the first thing we, of course, allied in order to work in cross-DC fashion with Kafka is to have a replication service. So replicate topics across data centers. So let's say we want to replicate the master replica of Elasticsearch to other data centers. That's something that Elasticsearch still doesn't work well with, so we wanted to do it ourselves, replicate it ourselves via Kafka. So here we actually created our own replication service. Of course, there are other solutions out there. You don't have to do it by yourselves, but here for us it was really trivial to use Greyhound. We used Greyhound batch consumer. So the original data center producer produces messages to Kafka, then they are consumed in a batch together in the replication service. And then they can utilize the ability to produce a batch via Greyhound to just utilize the Kafka SDK buffer. And so all this batch is also produced at once to the destination data center. And this is, for instance, a way to replicate Elasticsearch data and also other databases, other key value stores, etc. Now, how do we actually configure this replication service to decide which replication policies do we want to actually work with? So we actually use Kafka's compact topic feature. So Kafka topics can be served not only as for message streaming, but also you can think about them as storage. So compact topics are actually be thought of as key value stores, where values are stored as the latest value is actually stored, and you don't like delete 1 week ago, you just delete stale values. And so in our Greyhound back office, we have developers able to create new replication policies. Then we just keep them in this Kafka topic, and we just load it up into memory in the replication service. So the key will be a topic, and then the value will be what is the replication policy. So do we want to replicate across all data centers? Do we have like a custom replication policy between this data center and this one? And here we're back in our back office on the topics replication view, and we just specify, we choose the topic and we specify the policy. So it could be all data centers, only the main data centers, like replicate between passive and active data centers maybe, databases, sorry. And that's developer's way to choose. But developer really needs to think about what he's doing here, or her or she's doing here. It's not that trivial to set up your configuration in a globally distributed ecosystem. So we wanted to simplify this situation in cases where you may have services deployed in data centers that have read-only replicas of your database. So for that, we actually added for Greyhound the ability to specify, I want to produce to the main data centers to get the events streamed to the main data center, so they will go to the main database. So how did we achieve that? So basically, you have the Greyhound producer, and you just specify two main DC, and then we have the main DC producer service that will produce. So we basically have a gRPC producer, a special kind of producer inside of Greyhound that just sends a gRPC request to the main DC producer, and then it will know to reach this HTTP request, this gRPC request, knows to reach the main DC according to the HTTP routing rules. And then this event can then be, from gRPC request, be transformed to a Kafka event, and then processed by services found on the main DC, and we can save the data safely and have conflict-free and consistent databases, which is very important. So Okay, that's nice. So now we don't have to worry about, if we know that we are deployed in read-only database data centers, then we write this down. But it still has a lot of constraints here. We really still need to think about where our services are deployed, how are they deployed, are they in only in main DCs, in all of DCs, what's going on? So we thought we want to simplify even further. We want to have complete freedom of deployment. And we also want to decouple producers from consumers. I mean, what's great about event-driven design, that your producer, when you produce the message, doesn't care who consumes it. It's not interesting. It's the responsibility of the consumer. The consumer, he has the control here to consume messages and decide what they want to do with them. So we thought we're working on just having messages produced and magically get consumed in the correct data center. Now, it's not really magic, because what we're working on is just having a dedicated state of topology for each topic where its consumers are residing, in which data centers our consumer groups are running. Now, remember that we have Greyhound in all of our services, so it's really easy to change Greyhound if needed to actually provide the state, and we already have it for a long time, so all we need to do is to maintain this state. And now what's left is for our replication service to get this new produced event and check the current topology, and then it can say, okay, I know that we have consumer groups found in this DC and that DC. Great, so I'll replicate the messages over there. And now the consumers that know what to do, they have control here. We have consumers deployed next to our master active database, because this is, we control the service that is going to write to the database. So we create a Greyhound consumer there, and this replication service in Greyhound will make sure that it will get all the events that it requires. So now, in this setup that we've created, we can think about having a single logical Kafka cluster that's serving all of Wix services, no matter where they are deployed, and have like a sort of one global data mesh. And with the power of Greyhound, we actually have any technological stack at Wix actually using this event-driven style with this infrastructure, and of course deployed anywhere you need. And Greyhound is, like I said, open source. You can find it on this link in GitHub, and it's currently available for JVM languages, like I mentioned. We're also thinking about how we were able to open source Greyhound as a service to make it easy, although that's a little bit more of a challenge in how services are deployed in each organization. But it has all the features that I mentioned: parallel processing, batch consuming, resilient consumer, etc. So I recommend you to check it out. And that's it for me. Thank you very much.